and welcome to this week's interactive stargazing and Mars opposition stream. My name is Ariel, and I'm an educator here at the Lowell Observatory. Today, we'll be spending this first half hour looking at objects through our 14-inch planewave telescope for you all to see. So feel free to send in any requests in our chat. And afterwards, we'll be looking at Mars through our Clark telescope and talking all about Mars and its opposition and what that means exactly. So to start off, we will be looking at the object NGC 891. Now, this object is an edge-on unbarred spiral galaxy about 30 million light years away. It's located in the constellation Andromeda, and it's a part of the Virgo supercluster of galaxies, which our Milky Way is also a part of. An edge-on galaxy means we're viewing this galaxy at its edge. So those spiral arms where the star formation is occurring kind of looks like that dark, dusty lane to us. I kind of think of galaxies like fried eggs, where you have the yolk, that's like the galaxy center, and the whites are like the arms and the rest of the galaxy's contents. In this view here that we can see, we see the core of the galaxy's light. That's that brightest portion of that galaxy emanating from the center of the image. An unbarred spiral galaxy, which is the kind of object that this is, means that it's a younger galaxy that has a lot of star formation going on, and the center of the galaxy isn't barred, or the core isn't barred, and that's a barred galaxy is usually a common trait for spiral galaxies. What this means is that the center of the galaxy appears to be more like a sphere than like an oval or line or a bar. This galaxy was first discovered in 1784 by the European astronomer William Herschel, and this was also the first object that our Lowell Discovery Telescope looked at during its first light in 2012. Now, I see that there was a request to see Polaris, the North Star. However, where the planewave telescope is at our GeoValley Open Deck Observatory platform, the North Star is just behind the garage, so we can't quite grab him with this scope. So how about we jump on over to NGC 7662. Now, this object is called or I guess more well known as the blue snowball. This is actually one of my favorite objects to try to grab through a portable telescope or manually through a smaller telescope. This object is a planetary nebula about 4,000 light years away. So this galaxy was 30 million light years away. So looking at that galaxy, we were looking 30 million years into the past. This little guy, this little planetary nebula, we're only looking 4,000 years into the past. Right there, nice little dude. This object was also discovered in 1784 by William Herschel. So this guy was going on a roll. It's officially in the constellation Andromeda, but in the sky, it looks to be right between Cassiopeia and Pegasus. And what a planetary nebula is it's a dying star or a dead star. So a lower massed star or average massed star, once it runs out of fuel to burn or hydrogen to fuse in its core, it'll explode and it'll kind of expel out all of those gases and elements it's created throughout its lifetime. So that's why we get that little blue tint. So we're getting lighter elements coming out of this planetary nebula because there are we're getting lighter elements because it was a lighter star as it lived its life. Now, we've got lots of requests. M17 is the Swan Nebula, and I believe that we can grab that guy. Now, we saw the death of a star. The blue snowball is the death of a sun-like star. So in about 5 billion years, that's what our sun's going to look like. However, these stars are formed from these giant molecular clouds of gas and dust called nebulae, or a nebula. The Swan Nebula is one of my favorites, but I think I'm biased because they're all kind of one of my favorites. And it looks like a little swan. It looks like a little swan kind of hanging out in the sky upside down. It's along that line of the Milky Way. So if you're looking at the sky tonight, I believe viewing is pretty good. Ooh, wow, look at how nice that is. He looks so good. Viewing is pretty good tonight. If you happen to be in Flagstaff, Arizona, looking up or in a dark sky in general, you'll be able to see that Milky Way. And from Arizona, the Swan Nebula is kind of in the southern sky along that line of the Milky Way. So these nebulae have enough gas and mass and dust to form tens of thousands of sun-like stars. And the star formation will take hundreds of millions of years. So it doesn't happen very quickly. But if you kind of like tilt your head upside down and squint a little, you can kind of see the swan. There's that body of the swan, the neck and the head kind of going down into the left. That darker area kind of in the center of that view is a dark nebula. So there's that gas that's forming those stars, but it's being not being lit up, or those protostars, those baby stars, are either in the gas or like way behind the gas. So it looks like there's like a dark streak, but that's just gas that's forming those stars. We could try the double. So Epsilon Lyrae 1 and 2. This is a binary star system. I think it's a binary star system in the constellation Lyra. So what is going on with the binary system is we've got two stars that were formed most likely in the same nebula, so that same gas cloud, and they formed pretty close to each other. So they actually formed a gravitational pull to each other, and these stars are going to orbit around each other. Now, this double is interesting. Are we able to break up the double? Well, we're able to see that there are two stars here, but when you're viewing this star or these stars with your naked eye, it looks like a single star. And binary stars are very interesting because over half of the stars in our night sky are actually binary star systems or multiple star systems, where it's two stars real close together, orbiting each other, orbiting that center of mass. But to our naked eye, it just looks like a single star. I think of these guys kind of like the suns in Star Wars, like on Tatooine. So if there was a little exoplanet orbiting those stars, it would have a couple suns visible. So let's see. We saw M76, the little dumbbell. We may be able to try him. It might be a little faint. Yeah, so the little dumbbell, I believe, is another planetary nebula. So we have the Dumbbell Nebula, and then there's like the little dumbbell. So I guess they weren't too original with their names there. But the little dumbbell is another planetary nebula. So we have another death of a sun-like star, and we'll be able to see those. We might be able to grab some of that gas and some of that color in the image. I think we're zoomed in on the MalinCam software. And just to recap, we are using our 14-inch plane wave telescope. This is a live feed from the Lowell Observatory. We are using our MalinCam software to show you guys all the neat stuff that we're looking at. Nice. Oh, he's in there. Cool. So this is neat. So the blue snowball, we kind of just saw like a ball that looked blue, like the blue snowball. With a little dumbbell, we're actually able to see some color difference. So we're actually seeing different elements that star's formed in its lifetime, and those elements being kind of expanded or expelled out of the core of that star. So we're seeing those blues and reds, and those are, again, lighter elements. So we've got stuff like oxygen or hydrogen or helium, stuff lighter on the periodic table. Now, I know we got a good deal of requests from Tom Sarko. So let's see. The North American Nebula is too large to view. What was it? Goodness. Are we able to view the Helix Nebula is actually too large to view. But the Saturn Nebula we can grab onto. I believe that's NGC 7009. Planetary nebulas are neat little dudes to look at. It's nice, or it's interesting that even though the same sort of demise meets these lower mass or average mass stars, we get such different outcomes with these planetary nebulae. So Saturn Nebula is a tiny little guy right in there. It sort of looks like the blue snowball, but I believe it's called the Saturn Nebula because it has that circle, and then just kind of on the outsides, it looks like it almost has rings. That's just how the gas came off of that white dwarf star, came off of that dying core of that star. Betelgeuse, I see we have a request for, however, he is not up yet. If you happen to be out and about at like midnight, he will be visible in the night sky, or like 11:30 is when around the time when he rises. Now, see Melotte 20 or Melotte 20. That can be viewable, but we won't be able to get the entire image in the view, but we could still try it. Melotte 20. I have never heard about that. I believe it's an open star cluster. We might be able to grab him. Open star clusters are a few thousand stars that are bound together by gravity. So we have, tens of thousands of stars all bound together, but there's a weak gravitational pull for open star clusters. So what ends up happening there is over the course of a few million years, those stars will actually drift apart from each other because of a weak gravitational pull. And that is why they're called open clusters. So it kind of looks like those stars are opening up. Open clusters usually will have stars that appear to be more blue toned. What that means is that they're younger stars. So open clusters in general are younger clusters compared to their old grandpa globular clusters. So younger star clusters, and they're slowly drifting apart from each other. I believe we're typing in the right ascension and declination of this object because it wasn't in our little cheat sheet. So yeah, since this object is pretty big in the sky, we can't really grab the entire thing because we've got actually too good of a view through the 14-inch plane wave. But we are able to see some of those stars visible in the view right there. The Superman galaxy, NGC 7479, requested by Bob. I would love to try to view the Superman galaxy. So NGC 7479. I actually don't think I have ever viewed this object through the plane waves before. So since we're looking at a galaxy, we're going to be upping the exposure time a little bit, meaning like the open cluster that we were just looking at, we had an exposure of 6 seconds that we can see at the bottom of the screen there. With a galaxy, we'll up it up a couple seconds. What that means is that we're kind of piling on images every second. So having that shutter open for a longer period of time, like the shutter on a camera, to grab a little bit more light. Oh, nice little guy. Nice little guy in there. Cool. So we can see the center of that galaxy's core. And then it looks like that may be a barred spiral galaxy. So you can see that bar in the center. There's the core of the galaxy and then the kind of lines going through it. That's the barred part of the galaxy. And then the spiral is kind of that whoosh, perfect, going around the center there. So this is a younger galaxy. Again, spiral galaxies, they're still a couple billion years old, but we do have active star forming going on there, as we can see with the those arms in the galaxy. I like that. That's cool. I've never seen that guy before. The moon right now is behind the tree line. I wish you could see it, but we can't quite see it right now. However, Neptune, I see, we could totally grab. So Neptune is the 8th planet in our solar system, one of the 2 ice giants. So he'll appear as like a little blue dot in the view. So you can definitely tell the difference between the star and the planet. So you may also notice if we were to zoom in to Neptune, it kind of looks a little fuzzy, or like it's moving around a little bit. Are we doing that at all? Nice, yeah. So that's because of atmospheric turbulence. Also, we're using video mode now. So in previous images, previous views, we had the exposure set for a couple seconds. Neptune's not visible with the naked eye, but it is still close enough and bright enough to where we don't need to take long seconds of exposure. We can just take a couple hundred milliseconds of exposure and we can grab that guy. So is that just to the right of it one of the moons of Neptune, or is it just like a little hot pixel? Not completely sure. But a neat thing with the ice giants is because of their chemical content, specifically their carbon content, Uranus and Neptune both, some astronomers believe that there are diamond oceans with diamond bergs kind of scattered throughout the planet, and it rains diamonds. So that's pretty metal. However, if you were to try to take some of these diamonds, the wind speeds are incredible. These planets have naturally approaching supersonic wind speeds. So you get a bunch of diamonds, but you also blow the skin off of your body. So like, I don't know. Pretty close. Now, what is happening in Orion's belt, I see from Jasmine. So there is the Orionid meteor shower tonight, but we won't be able to see Orion tonight. He will be rising a little too late for us to grab anything like Betelgeuse or the Orion Nebula. But if you guys happen to be out and about during, I believe like around like between 2 to 4 a.m., that's when you'll be able to catch some of those meteors in the meteor shower. We grabbed the Superman galaxy. Cool. So how about we try to jump over to Uranus just to see we might be able to grab a color difference between Uranus and Neptune. Now, Uranus is the 7th planet of the solar system. It is another one of those ice giants I was just talking about. And Uranus, before it was named after the god of the sky, it was named George. Could you imagine? You know, Mars, Jupiter, Saturn, George, Neptune. No, thank you. It was named George because that guy I was talking about earlier, William Herschel, he did a good deal of discovering a bunch of stuff, and he discovered George back in way back when, and he wanted to name it after his king, so King George. And there was like a century of argument over what this planet should be named. You know, he wanted to name it after his king. A lot of people were like, "Oh, we should name it Herschel," but like Herschel sounds just about as good as George does when we look at the whole lineup of the planets. So eventually, we named it after the god of the sky, Uranus. So we could grab the Perseus double cluster. I think we have a pretty wide or a narrow view, but I think we could grab him. I'm not completely sure if we can get both of the open clusters in there, but the Perseus double cluster is another one of my favorite objects to try to grab through a telescope or through like a portable telescope or a manual telescope. It's actually visible with the naked eye just between Perseus and Cassiopeia. Nice. Okay. So what we have going on here is an open cluster again. So those stars that are slowly drifting apart from each other because of that weak gravitational pull. And this double cluster is very interesting because we don't see this very often, where we have two open clusters very close together. So we can usually get these two clusters in the same field of view. Some astronomers believe that these clusters formed from the same nebula. So that nebula, that big gas cloud, split into two, and then all of those stars formed pretty close together, and now they're slowly drifting apart from each other. So in this view, we can only get one of those open clusters here. So because we're actually looking in too far, we're zoomed in too much. Again, our view is too good. So we could try a globular cluster. Could we try M15? Now, Globular clusters, you'll be able to see the visual difference between an open star cluster and a globular star cluster. Open clusters, you can see that those stars are kind of clustered together, but they're kind of dispersed, versus a globular star cluster. Some of my favorite objects to look at through our Clark telescope, actually, we see hundreds of thousands of stars all bound together by gravity. So astronomers thought of the very sciencey science term glob. So M15 is also known as the Pegasus cluster. So this is a globular star cluster about 33,000 light years away, I believe. So we can see, just how different this view is compared to those open star clusters. Where in the center, we have that center of mass, which looks like salt spilt on a black piece of paper on a black table with how many stars are in this glob. This guy has a couple 100,000 stars, all bound together by gravity. So all those stars are globbed together, and they're all kind of orbiting about that center of mass where all of those stars are bound together pretty strongly. Globulars also differ from open star clusters because they stay globbed together. So open star clusters, as I mentioned earlier, open up and they slowly drift apart from each other because of the weak gravitational pull. But globular star clusters, there's so much mass, there's so many stars, so much gravity that they stay globbed, they get globbed, and they stay globbed for forever. And it's kind of weird to think about because, all of these stars, it looks like there's, so many so close together, they got to be bumping into each other, but there's like light years of space. There's like over 100 light years in diameter from, edge to edge for this globular star cluster. So no real star bonks, no real stars bonking into each other. So we could try the Sculptor galaxy. So we looked at the Superman galaxy earlier. We saw NGC, was it 981 earlier? Now we can see a different view, or a different galaxy. So as we're moving to other objects, we see these streaks or stripes in the frame. Those aren't like satellites or shooting stars or anything. It's just as we were taking an image, we were moving the telescope, so it'll look like stuff kind of shifts across in the screen. That's a great galaxy. That looks really good. So Sculptor galaxy, we can, again, kind of like, I think galaxies like fried eggs or like plates. So we'll see them, edge on, we'll see them face on. We can see them in all different positions in the sky. This guy isn't quite edge on, so we can actually see the core of that galaxy, where hypothetically that supermassive black hole, that gravity can be felt tens of thousands of light years away, holding that galaxy together. We can also see those dust lanes in that galaxy. So those dust lanes, again, that's where a lot of star formation is occurring. So we've got hundreds and hundreds of nebulae and gaseous regions in those spiral arms. We'll also get stuff like globular clusters hanging out in that galaxy, and other clusters and planetary nebulae. So let's try. Are we able to grab Jupiter? Is he still up or is he pretty low? I think we're going to try to grab Jupiter. So Jupiter is the first of our gas giants. It's also the most massive planet in our solar system. Like if you were to combine every planet twice, you still would not reach the mass of Jupiter. So we've got this massive gas ball. Here in this view, we can actually see all 4 of the Galilean moons. So these are 4 of Jupiter's, or the 4 largest moons of Jupiter. However, Jupiter is so massive, it has more than 80 confirmed moons. It's just, those are the easiest to see. So all those dots in a line there. We can zoom in here, and we might be able to grab some of the storms or the lines on Jupiter's surface. Nice. So we have these storms made of different gases going hundreds of miles an hour in different directions. on that surface there. So the white stripes on Jupiter's surface kind of acts like a sunscreen for Jupiter, made of those, I believe, helium and ammonia clouds, and those darker stripes are hydrogen clouds. So those darker hydrogen stripes are basically Jupiter's tan lines. How about we try Saturn? We'll try Saturn. Saturn is the last of the planets that we can see with our naked eye in the sky. So Mercury through Saturn, you know, ancient astronomers and ancient humans have known about for forever. And it wasn't until actually the invention of the telescope in the 1600s where we started looking for other planets like Uranus and Neptune. But Saturn, we'll be able to see the gaseous body in the center there, as well as the rings going around it. Nice little guy, a little bug in there. Saturn's rings are only about 60 feet thick, so they're incredibly long. You know, they extend out like twice the length of Saturn's gaseous body, but they're only about 60 feet thick, and they're made of primarily space rock and water ice. So if you were to go and scoop up some of Saturn's rings, you'd have a nice little rock smoothie. We're not going to talk about radiation or anything. So yeah, the same thing that we saw with like Neptune and Jupiter a little bit is we'll see kind of like fuzziness or moving in the eyepiece. And that's because Saturn is kind of low in the horizon. So we're looking through extra atmosphere. We're also doing that video mode again, where rather than taking a couple seconds of exposure, we're only taking a couple milliseconds of exposure. So we're able to see that, again, that gaseous body and those rings. The chemical components, I guess, or the stuff that makes up Saturn is actually pretty similar to Jupiter, but Saturn is not dense at all. Like if we were to find a Saturn-sized swimming pool, Saturn could hang out in the pool and it would not sink. It would actually float because of its lack of density. It's also made, it's made of the same elements that Jupiter is made out of. However, those stripes and those like stripes and storms that we see so easily on Jupiter are lower in Saturn's atmosphere. So it appears kind of like it's just like a creamy yellow color rather than those white and brown stripes. Saturn's rings, we believe, how did Saturn's rings form? We believe that through tidal forces. So whenever like stuff comes close to large masses like Jupiter or Saturn, the forces of gravity can actually break apart these physical bodies. So Saturn could have had, way more moons. However, those moons or a moon or a few moons, these smaller bodies than Saturn were broken up and kind of expelled themselves out and about and around Saturn. We actually think something like, not as dramatic as Saturn, but something like that will happen with Mars in a couple million years. Mars has 2 moons, Phobos and Deimos. I believe the closer moon is Phobos, and we think in a couple million years, Phobos will either crash into Mars' surface, creating a really large impact crater, or it will break up into a very small planetary ring. That moon is like 9 miles by 7 miles, so it's not an incredibly large moon like the moons of our gas giants. So if Mars did have a ring, it wouldn't be very noticeable, but it would still be kind of cool because none of our terrestrial planets really have rings. Terrestrial meaning solid surfaces. So we just moved on over to Mars. Looking at them through our plane wave telescope, we can see it's the very red surface, that Martian surface. We can also see some of the Maria on its surface. Ancient lava flows are evidence of ancient volcanic eruptions. So that darker portion on the upper left-hand side is evidence of ancient geology happening on Mars's surface. So with that, the interactive part of the stream is just about finished here. So I believe now we should be moving on over to Klaus, Bill, and Kevin to talk more in depth about Mars. So thank you guys so much.
Hello. Hello.
Hi, Bill. Hello.
Welcome to Halloween in advance from Mars Hill.
Hello, Kevin.
Suspicious-looking characters. Nobody realizes that we're within a few feet of each other in different offices in the Slifer building.
We're taking precautions, and we're also planning our invasion of Earth very carefully. We're not going to reveal our plans until the time comes, and we'll return your TVs back to yourselves. 222 years ago, 122 years ago, a very interesting book was published that was inspired in large part by what went on here on Mars Hill and some of the observations that were made here that were extremely stimulating to the human imagination. And let me just set the stage for you. This is not a live radio telecast. You're quite safe as long as you don't have any tarantulas crawling around underneath your chairs. Ladies and gentlemen, the director of the Mercury Theater and star of these broadcasts, Orson Welles. We know now that in the early years of the 20th century, this world was being watched closely by intelligences greater than man's and yet as mortal as his own. We know now that as human beings busied themselves about their various concerns, they were scrutinized and studied, perhaps almost as narrowly as a man with a microscope might scrutinize the transient creatures that swarm and multiply in a drop of water. Yet across an immense ethereal gulf, minds that are to our minds as ours are to the beasts in the jungle, intellects vast, cool, and unsympathetic regarded this earth with envious eyes and slowly and surely drew their plans against us. And that was Orson Welles speaking over the radio on Halloween 1938. His famous Invasion from Mars broadcast, which was based on H.G. Wells's book published in 1898, The War of the Worlds. And,
Bill, can you pardon me? I'm going to go cash out my savings account after hearing that. So I'll be right back.
There are traffic jams on the edge of Mars Hill as people are fleeing during that announcement. And of course, anyone that's a fan of science fiction is well familiar with those words. And they were inspired by Percival Lowell's theory that Mars was the abode of intelligent life, that it was a planet that was well advanced in its evolution, somewhere between youthful planets like Jupiter and Saturn, which were still gaseous, and the moon, which was utterly dead, and that Mars was more advanced than the Earth on its career towards ultimate death, evolutionary death. And so it was losing its water, its atmosphere, and the Martians, in order to stave off doom, had to build a system of canals, which Percival Lowell believed he was able to see with the refractor probably about 100 meters from here. And Lowell started a whole raft of wonderful science fiction by promoting that theory. Lowell's Martians, Kevin, how would you describe Lowell's Martians? What were his Martians like in his imagination?
Well, he made it clear that they weren't like humans. He made the point that, different conditions are going to make them look different. So he never envisioned little green men or anything like that. In fact, I don't think ever wrote about what he thought they actually looked like, just that they wouldn't look like us
They
because they had
wouldn't
adapted.
wear straw hats and pants.
And that's something that really Klaus could comment on, because things adapt to their conditions, and so there's some evolutionary biology in there. To Lowell's thinking that who knows what it's going to look like. Just it's going to be different than a place like on Earth with our gravity and our atmosphere of nitrogen and oxygen and so on.
Yeah, I think that what Lowell envisaged, and actually that also precedes him in the 1800s and even the 1700s, a lot of people were convinced that every planet in our solar system, including the moon, and some people even thought the sun, was inhabited. And the reason for that was that people believed then in the doctrine of the plurality of the worlds, which essentially suggested that God would not create anything without a purpose. And that purpose, of course, would be us or other intelligent beings on other planets. And so whether they actually looked like us physically, that I don't think was discussed very much or speculated on very much. However, the idea was that intelligence would be the main moving factor in terms of how, various alien civilizations might react. And I think that's kind of what Lowell had in mind, without actually ever, imagining what a Martian, if his imagination, might look like.
And I think another important point with Lowell, he's often tied to the canals, and he saw those, supposed linear features on the surface as evidence of life. But his ideas of life on Mars really was more than the canals. If we go back to his time in the 1890s when he started the observatory, it had just been a few decades since Charles Darwin came out with the theory of evolution. And after he did that, which was, the biological changes over time, so many people jumped on that, and they used evolution to mean the change of both living and non-living things. And so this idea that planets evolve, and Percival Lowell really did a lot with this, what he called planetology. And the way he saw it was that, planets are formed, they're gaseous, like, Jupiter, Saturn, Uranus, Neptune, they're young. And then they age some. They lose some of that gas. They solidify, become terrestrial planets like Mercury and Mars and Earth. And then over time, they lose that atmosphere and become a dry, dead planet like Mercury. Well, in that stage of evolution, Earth is in the middle stage and we have life. And so there must be life on Mars also. It's got the atmosphere, it's in the right stage of evolution. So it made sense for there to be life. So I think there's a larger picture that he drew of why there was life out there. And, of course, today we know that a lot of those ideas about planetology aren't true. But it was, we're talking about ideas, more than a century ago. Science is a progress report based on the best evidence we have right now. This is the best explanation we have, but it changes over time as we make more discoveries. And so even though we might chuckle at some of the ideas now, based on the evidence they had now, there are some plausible ideas.
Yeah. One of the things that's interesting is that even though Lowell never claimed that he could imagine what the beings, intelligent beings on Mars would look like, he had all sorts of ideas of what kind of a society they had created. And it reminds me a little bit, there was a famous case of an Etruscan horse, which was supposedly the greatest example of Etruscan art that had ever been exhibited. And it was for many years in a museum, I think in England somewhere. Well, eventually it was proved to be a forgery. It was a Victorian forgery. And the people at the time could see some elements of Etruscan style, but they completely overlooked those that were the most familiar to them, which were the Victorian aspects of this sculpture. So I think Lowell thought that the Martians were technologically advanced, but by that he meant technologically advanced in the same sense that 19th century America or Europe was. And so the most advanced technological transportation systems at the time were, of course, railroads and canals. The Erie Canal had been built in the 1830s. That was later replaced by railroads. The Suez Canal, 1869. The Panama Canal took a lot longer to build and wasn't finished until the early 1900s. But the idea that the Martians, faced with this dilemma of their impending doom, would build a system of canals, and that the whole society would work in a kind of a collaborative way with the best people, the kind of Boston Brahmin type leaders on the top telling everybody else what to do, was Lowell's best guess at what an advanced civilization would arrive at. And he never imagined that even us, backward Earthlings would be, achieving powered flight. We'd be sending rockets to other planets within a century. And so it's interesting to see what he imagined and what he wasn't able to imagine. But the rocket thing is interesting because Lowell's ideas inspired H.G. Wells, who had a little bit different take on the psychology of the Martians, because Lowell thought that the Martians would be these very benign, peaceful folk, very, very collaborative and peaceful in nature, working together to stave off this impending doom. And Wells realized that it was a lot better from the standpoint of telling a story to have them as evil and essentially malevolent creatures. And so the Martians that he imagined coming to the Earth to invade by these sort of like capsules that were shot from cannons were essentially supposed to be towards our civilization the way that we were towards the Tasmanians or indigenous people, where we essentially exterminated them so that we could implant our more advanced civilization. So that's an interesting fact. Klaus or Kevin, can you tell us a little bit about kind of the way that the Martians were envisaged by Wells as opposed to Lowell?
Well, I have an illustration that might help. If you'll just let me share the screen for a minute.
You do that, or tell us in 1,000 words, your choice.
Yeah, we'll do that too. But I hope you can all see this. This is an actual illustration from a book printed in 1898 of what the Martians were described by H.G. Wells to look like. In fact, they had machines and weapons that we simply could not stand up against. And they came here solely, as Bill has pointed out, just like many of the colonial powers at the time of Lowell and before, built colonies, essentially subverted natives, whether it was in Africa, in North America, and Asia, for their own good, because they felt that, colonials felt that they could get cotton and gold and whatever and bring that back to the British Empire or whatever. So that idea then was that the Martians would treat us the same way because they were basically after earthen resources. And so in the process, because we had water and they were losing it, so in the process they sent these war machines, which then were invincible. And if I might just continue briefly, that same theme has been held throughout. Many remakes and movies of that story have been made. If any of you are old movie buffs, I strongly encourage you to watch this 1953 movie of War of the Worlds, because it was a superbly technologically movie advance and really was very well done. Quite scary.
It won the Academy Award for special effects that year.
That's right, it did, absolutely. And then several other versions of the movie have been made, including one of the more recent ones with a gentleman actor here that many of you may know from the movies, and that was made in 2005. And several other shows have been done like that. And in all cases, it starts off being invaded by incredibly technologically powerful and advanced aliens. Of course, the solution to the problem is something that Bill might want to pursue because he'd had an idea to compare that to what's going on today in many ways. Bill?
All right. I mean, one of the interesting twists of the plot is that all of the weaponry and martial virtue of 19th century British soldiers are essentially without any effect on the Martians, who just basically trample across the countryside at will, essentially. And if I might just make one parenthetical remark, if you go to Woking, which is where Wells was living at the time, you can actually find the very places where Wells describes the Martians' first capsule landing, the various towns that they pass through with their heat ray and their destruction. So it made it very, very real, very immediate to people at the time that were reading this because they knew these places. But anyway, in the end, the humanity and the rest of life on the planet presumably are rescued by the lowest of all life forms, bacteria, to which the Martians had no immunity. And this has a somewhat ironic and sad parallel because, as we know, the successes of the European colonists and missionaries were in large part abetted by the fact that many of the native people didn't have resistance to smallpox and other diseases, which decimated their populations. But in the end, the Martians are basically defeated by bacteria. And this also has a very strong contemporary resonance because, as we know, we are in the midst of a very devastating pandemic, which is produced by something even lower than a bacterium, something that is really hard to even describe as a living thing. It's just a basically encapsulated RNA strands, and this is the COVID-19 virus. So we tend, I think, sometimes to become a little bit complacent and perhaps even smug in our sense of our superiority, whether it's to Tasmanians, Native Americans, or whomever, and yet we too can be laid low by the lowest of all possible life forms. And that was certainly the denouement of the War of the Worlds, and certainly also something that it has a salutary warning for us. Let me add one other connection. So H.G. Wells's book was published in serial form in magazines, and one of the readers was a fellow named Robert Goddard, and I think Kevin is our resident expert on the history of the space program. So, Kevin, what can you tell us about the H.G. Wells Robert Goddard connection?
Right. Well, Goddard growing up read H.G. Wells, and supposedly he saw Percival Lowell give a lecture back east. Goddard grew up back east. And he became really fascinated with the idea of going into space. And so when he got older, he went into engineering, as it were, and was the first person to develop the liquid fuel rocket, which of course became critical to sending exploratory satellites and eventually humans into space. And so you have these different degrees of separation of people that all go back to Percival Lowell. And, it's interesting because Lowell, he came from this family that was really driven and really successful. And his father certainly implanted this idea that, if you're a Lowell, you have to do something important in your life to continue to boost the Lowell name. And Percival Lowell wanted to prove there was life on Mars. And later he wanted to prove there was life, or there was another planet in the solar system. And he wasn't able to do either one of them. And you wonder, it seems like he probably went to his grave unfulfilled because he didn't, succeed as a Lowell should. And yet in hindsight, you look at the impact he had, we know more about Mars. If you tie it to a single person, it probably goes back to Percival Lowell, because he inspired scientists to either want to prove him right or prove him wrong. The ones that he didn't really irritate and turn off to astronomy. But then there are and then you play that forward with scientists being inspired that inspired other scientists. And then you have, again, the unintended consequence of, Lowell built this consciousness of life in the universe. And that's what fiction writers write about, whatever is hot at the time. Imagine in the next couple of years how many novels we're going to have about COVID-19, because that's what's happening right now. Well, these writers like H.G. Wells and Edgar Rice Burroughs write these books, and then you have people like Robert Goddard and Carl Sagan and others reading the science and reading the science fiction and being inspired and going into science to learn more. So it's this really interesting continuum of science and science fiction repeating and inspiring future generations. And I don't know, Bill, I recall from our past conversations, certainly your first memories of astronomy go back to when you were a kid, and there's a lot of Lowellian ties to that.
Yeah, in fact, I mean, one of the things that the physicist Wolfgang Pauli said in basically contemptuous dismissal of a colleague's theory was that it wasn't even wrong. And let me read this little passage from Robert Lowell. He was probably the most talented of the Lowell poets, of whom there were several. But he wrote shortly before Viking landed on Mars, "Thanks for Percival Lowell. I hadn't realized his errors were so fruitful. I suppose that's the rule in science. In the family, we always doubted his Mars, but swore by the accuracy and orthodoxy of his Pluto, once to have been called Percival." So yeah, I think that's really the case. Percival's ideas really, it's a little like the passage in Shakespeare's Julius Caesar. Julius Caesar, thy ghost is mighty yet. Percival Lowell will always have a significant penumbral presence in any kind of Martian science that evolves from this point forward. And it's because of him that we are fascinated by the planet and have been ever since he set forth his ideas around the turn of the 20th century.
And Bill, I wanted to mention something about the literature again. And we were talking about the War of the Worlds. And I think that was published, like you said, in serial form that came out around 1898 in book form. And there are a lot of books similar to it. And I think it's interesting. I have a couple here that are kind of fun. This one is called War of the Worlds Global Dispatches. And I'm not much of a science fiction reader, but this one is written by different science fiction writers, and they take on a character that lived back in 1898 when the supposed attacks happened. So you have Theodore Roosevelt, Rudyard Kipling, Jules Verne, and the science fiction writers are writing as if those people experienced the landing. And one of the chapters is about Percival Lowell. And they're going to build these big bonfires to catch the attention of the Martians. And then Percival Lowell wants to be the one to go out and meet the Martians. So that scene ends as the hatch opens, he's about to shake their hand. Of course, the implication is, he never made it. And so, these books that have come out.
The astronomer in H.G. Wells' War of the Worlds that goes out to meet the Martians ends up incinerated by a heat gun. But, I'm sure Lowell would have had ways of getting through to them.
Well, one thing too that has happened in science fiction. I was very much a science fiction fan as a kid, and it really it fueled my imagination as well as astronomy to actually become a scientist. But I remember books like The Martian Chronicles, for example, by Ray Bradbury, and really it is a wonderful, wonderful critique of human behavior, because basically the Martians and the visitors that go, that they travel, the contact between humans and Martians and so on, shows, and several authors have written about that, again in science fiction. For example, another one by British author Edgar Pangborn, a book called A Mirror for Observers, is the diary of a Martian posing as a human who lives among humans in England and studies their behavior and their idiosyncrasies and so on, with the idea that the Martians, who humans don't realize exist, will at some point assimilate humans, but the Martians in that book actually look like humans because they transform themselves to look like humans. And so basically the observer who's been sent by Mars to study humans and look for their frailties and so on, soon discovers that many of the things that the Martians think are beneath their dignity turn out to be endearing. And so he actually falls in love with humans and doesn't want ever for the Martians to come and invade the Earth. So there are all kinds of, socio-political, philosophical twists in some of these science fiction stories that essentially stem back to Percival Lowell, because of his idea that, Mars was inhabited and that the Martians were intelligent and that they were trying to save their civilization by building canals and to tap water from polar caps. And also, let's never forget, at the time when Percival Lowell was living here in Arizona and he was setting up this whole theory, this whole business about Mars and canals, Arizona itself was considered a desert wasteland, and the only way to improve it was to build canals. And so there were all kinds of discussions and arguments back and forth and political discussions and debates in the newspapers as to how much water, how many canals, etc., should be built in Arizona. So as Bill said, at that time, canals were sort of the high technology of civilization. And definitely Lowell was influenced by that, and others were influenced by Lowell to sort of make the desert bloom.
And looks like we have some questions, so let me just cut in here.
All right.
One question was, is the Syrtis Major a lava plain? It is sort of a lava plain. It's actually, though, a plateau rather than a plain. And there is a not very often mentioned small shield volcano called Nili Patera, which is the source of the basalt, which covers that region and makes it so prominent. Someone also asked if any seismic activity has been detected on Mars in the past few years. I don't know the answer to that question. Do you, Klaus or Kevin, know?
Yeah, let me just share my next slide so we can take a look at the structures that, there we go. Here, let me enlarge that, get Bill out of the way. Here are some of the features that you have probably seen or will see on Mars. These are images that I've taken with my little backyard telescope beginning September 29th, and the most recent one here, as Mars gets closer in opposition. And this big structure here is Syrtis Major that one question was all about.
And the shield volcano is about right there. That's about where the shield volcano lies, if you can see my arrow.
Where the arrow is?
Yeah, right here.
That's right.
It's just a little shield volcano there.
And then this is the polar cap for those who are just tuning in. And the reason these images are different colors is not because Mars changes different colors, but because I use different filters in taking my pictures to bring out different types of detail.
And I'd like to jump in there just for a second for our friends who are watching. And this is a great opportunity to talk to a couple of people that are really experts in Mars around the world. Klaus has gone back and looked at a lot of the astrophotos of early astronomers such as E.C. Slipher, who did some of the first image stacking. and has now taken that to the modern to interpret just how valuable the work was that E.C. Slifer did. And then Bill is working on his latest book about Mars. I've got a couple. Here's one that he's done. And he's done several, and he's about to come out with another one, kind of an updated version about Mars. So this is a really great opportunity to talk to a couple real leaders in all things Mars. So I'll leave that plug with you guys and then let you go on.
All right. So I don't know that we haven't. Did either of you know anything about seismic activity on Mars?
Yes.
Mars doesn't have a molten core, iron core. So obviously, but it has had volcanic activity, and there certainly are some major faults like the Valles Marineris canyon complex, and so I would assume, as with the moon, there are small Mars quakes and things like that, but I'm not really very up to date on that literature to be more specific. But yeah, I think that one of the space probes, I think, is might be InSight. I think is looking at some of those kinds of questions in terms of new seismology on Mars, which of course would be a source of a great deal of valuable information about the Martian interior. But I just haven't really kept up with that literature to be able to say more. All right. Well, shall we continue with the science fiction related to Mars? I think this might be a little bit of an add-on to what Klaus was talking about. But one of the things that Percival Lowell certainly did with his ideas about Mars was that he established as a sort of a trope for science fiction that it be on desert planets. Many of the planets that science fiction writers envisage, not all, but many of them are deserts. And I think that in part that is Lowell's influence. And that began actually with Edgar Rice Burroughs, who started out his John Carter science fiction tales about Mars, which the Martians supposedly called Barzoom. That was their name. And he talked about the hurtling moons of Mars and romantic things like that, which inspired young people like Carl Sagan to become interested in the study of the planets, because it was so captivating to his adolescent imagination. But John Carter started out a Virginia soldier in a cave in Arizona, where actually Edgar Rice Burroughs had briefly been associated with one of the forts, Fort Apache or something, I think, and envisaged Mars largely in terms of the Arizona landscapes. And it has been argued that Percival Lowell, too, at least absorbed some of the landscapes around Flagstaff, particularly the view of the Painted Desert, in conceiving his idea of Mars as this world of lush orange-red colors with these fields of verdant vegetation growing on top of that. Okay, there's another question. Al Jazeera crater. This is a crater that is in an area where there are old river valleys. And the interest is really to try to basically bore down on an area which shows significant sedimentation, that shows evidence of past water erosion on Mars, and not only to study that area initially with the rover, but also eventually to be able to excavate some material that can be brought back to Earth by a future spacecraft, so that these elements of the Martian soil can be analyzed in a laboratory back on Earth. So essentially, Al Jazeera was chosen as a place where conditions were felt in the past to be at least suggestive of the possibility of the origin of life back in the early days of Mars, when there was much more liquid water on the planet than there is now, and to explore that possibility. So that's why that particular feature was chosen after rigorous evaluation of a number of sites. That was the consensus one that the investigators chose.
You know, it's an interesting legacy. This is the latest example to look for life on Mars and water on Mars. But we go back to the Vikings in 1976, looking at soil samples to look for any fingerprints of life, and really we don't have to go much further back than that, back to the 50s or so, when a lot of astronomers still hedged their bets that perhaps there could be life out there. Not until the Mariner started getting close-up images, where the canals really stopped showing up on maps, because
Right.
there was this, even though most astronomers for decades realized there's probably no life there, I think to some degree there's probably a hope that there was. The idea that we might find life elsewhere, and they're still kind of hedging their bets that perhaps there could be, until spacecraft started to get out there. And now we're, looking not just on the surface like those early ones did, but now below the surface.
Well, along those lines, I'm sure some of you remember the Viking missions to Mars. They were two of the most successful landers ever. They were huge machines, very complex. Launched in 1976, basically under the direction of Carl Sagan. And experiments were designed to dig into the soil and essentially see if there were any evidence of bacteria. And some of the early data suggested that there was, but then eventually it was more or less decided that the chemical reactions that were being observed were actually chemical, not biological in nature. And so at the time, people were kind of discouraged. But nowadays, it's become even more of a drive. Essentially, the notion of looking for life on planets and moons in our own solar system, as well as looking for biosignatures around exoplanets that we have discovered since, has become a big driving force behind much of the space exploration that's being planned. And that's a very, very exciting question, because if you think about it, let's say we do find evidence of life, simple life on Mars in the past, then the question is how similar or not is that to life on Earth? And that would make for a very interesting debate and questions. For example, if life on Mars is based on DNA and protein, as all life is essentially here on Earth, that would suggest that maybe in the past there was cross-contamination. If it's not, if Martian life is based on a different kind of biochemistry, then that tells us that it originated independently, and so forth. So there are a lot of exciting questions that I'm sure we'll be getting answers before.
One of the things is just the statistical question. I mean, right now we know that there's life on Earth, but we have an N of 1. It's the only planet on which we know that there's evidence of life for sure. And that would be just like if you found a pig that was able to run the 100-yard dash in under 9 seconds, you wouldn't know whether that was a unique pig or whether all pigs.
Bill, only you would come up with something like that. There's another question here from William Bailey asking the usefulness of planetary filters for small aperture telescopes, 4 to 6 inches. Good question. When it comes to Mars, definitely using filters is a very good idea, because if you can use a red filter like I did in some of the photos I just showed you, it then helps to stabilize the atmospheric turbulence, but also increases the contrast of the dark features. On the other hand, if you use a purple or violet filter, you won't see much of the surface detail, but you'll enhance the views of the polar caps and possible clouds in the Martian atmosphere. And similarly, you can use color filters to bring out more detail on the cloud belts of Jupiter using a combination of filters. And same with Saturn. So yes, it's very much useful to have, even on small telescopes, filters.
And I have since we don't have another question yet, I have a almost completely unrelated thing to mention, but because I like baseball, I'm going to mention it. That we're talking about Mars tonight, and all that Percival did with that. But of course, we're not talking about Pluto, but that was a whole different part of his efforts looking for a ninth planet. And he didn't discover it, but years later, Clyde Tombaugh here at Lowell Observatory, in searching for Percival Lowell's planet X, discovered what we know today as Pluto. So we have a trivia question, and the first person to answer it will get a book about Lowell Observatory signed by Bill and Klaus, and I can do that too tonight. And the trivia question ties in with the World Series tonight. What player who played tonight in the World Series is related to Pluto discoverer Clyde Tombaugh? And so the first person, I'll rely on Heather to figure out the first person to answer that correctly, and you'll get that free signed book. So with that, I'll turn it over to you, Bill. I'll let go of the unrelated minutia.
I like that. Good show, Kevin. That's great.
Yeah, I can answer it. I'll have to buy the book. Oh, somebody just popped it up.
No, don't say it. That was me.
Oh, I'm sorry.
Because Heather wanted us to know the answer.
Gotcha. Well, let's talk a little bit more about life on Mars and all of that sort of thing. And of course, we one of the things that inspired Carl Sagan's interest in life on other worlds and astrobiology was that he was at the University of Chicago at a time that a chemist named Stanley Miller had a kind of a kooky idea of basically putting some chemicals into a flask that he thought might somewhat be similar to those that would have been in the atmospheres of the giant planets early in their history, like gas like ammonia and methane, and shooting electric sparks through that while it was being basically kept moist with a stream of water vapor going through it. And his advisor at the time was a Nobel laureate chemist named Harold Urey, who was very skeptical of the whole idea, but eventually he agreed to this kooky idea of Stanley Miller's to allow this to go forward. And what was found after a few days was pinkish goo, which turned out to contain some of the amino acids which are common in living organisms. And so this was a first shot across the bow that really led people to think, well, perhaps on planets early in their formation, that are either being where the shocks are either coming from electricity from thunderstorms or perhaps volcanic eruptions, that life might form on its own. And there's quite a bit that's been done subsequently to support the idea, particularly in these deep ocean volcanic vents, where all sorts of rich chemicals exist, and numerous exotic life forms have been discovered deep in the bottom of the ocean. So that's certainly one possibility that life formed on Earth in that way. And these life forms are extremely diverse in terms of their metabolism. Some of them are basically able to survive eating sulfur and other compounds of that sort and metals, whereas there are also some that are, more methanogens. They survive on methane and other toxic substances that would kill us. And actually, even oxygen is poisonous to a lot of these microorganisms, and we've had to develop all sorts of protective chemistry like antioxidants in order to cope with oxygen once photosynthesis started on the planet. So the question then is, as Klaus was saying, if we do find life on Mars, and it's similar to this, that we found on the Earth in these places, then one would assume that life must be fairly easy to put together under the right conditions. But it would be very interesting to see in what ways it might have differed. On the other hand, if it turns out that the life on Mars is identical, because life is extremely complicated with all sorts of interesting and exquisite adaptations, then you'd have to really assume that life basically formed somewhere way out in space and then seeded the universe, maybe through the clouds of different stars jostling with one another, and or some of these strange interstellar interlopers like Oumuamua or whatever it was called, I'm not sure how to pronounce it, that was seen as an interstellar comet sweeping through the solar system, that essentially it's a little bit like the spread of a virus. Once it forms somewhere, then it the whole universe becomes contagious to it, and it kind of spreads through time, and maybe that's how it arrived on Earth. There are even astronomers, biologists who believe that life might have formed on or seeded the atmosphere of Venus. And there are some observations of the clouds of Venus that are suggestive of that. So we don't really know whether we're just sort of loners in the universe that are essentially all by ourselves, and that's a kind of a frightening thought, or whether the universe is teeming with other life, which is maybe even more frightening thought. So we're sort of caught on the cusp of this dilemma of whether we're alone or whether we're, just unaware of the fact that we're living in a neighborhood of aliens.
And that as you're talking about that, it reminds me of Carl Sagan, one of the people inspired by Percival Lowell, who said, extraordinary claims require extraordinary evidence. And that's certainly, when we're talking about life out there, there's been reports through the years of life like the Martian meteorite ALH 84001 back in the 90s, and others that looked promising but didn't stand the test of time.
Well, the main issue, I think, as a biologist, from my standpoint, is that you can imagine all kinds of weird and wonderful forms of life. But if we start looking out as astronomers are doing now, we're finding the building blocks to life as we know it all over the place. For example, even Pluto, for instance, which nobody expected to be anywhere near possessing anything organic, turns out it's coated with a brown veneer that is all basically breakdown products of organic compounds. If we look at the distant objects, stars, nebulae, galaxies, and so on, we can see spectroscopic indications that complex organic molecules are widespread even in the interstellar medium. So from the standpoint of the scenario that Bill just touched on, it is entirely possible that life is broadly based across the universe, and it's also possible that it would use the same kinds of molecules that life on Earth has, namely carbon, nitrogen, phosphorus, etc. The question then becomes, if you have these basic building blocks, it's one thing to have common bricks, but the design of any living creature would be more like the architect designing a different size building. They're all made of bricks, but the bricks is the common thing. The ultimate design or the evolutionary development of life on other planets might be quite different, and probably would be.
Let me follow up on what you just said, and then there is another question about the mechanisms involved in loss of water in the early history of Mars, which we'll get to. But I just, while the thought is fresh, strike while the metal is hot. So one of the things that inevitably we tend to forget when we have this discussion is that the kind of life that we're most interested in isn't like Tholins on Pluto or anything like that. We're really interested in life like ourselves, intelligent life, technologically sophisticated life. And let me just point out that the sun and the planets, including the Earth, are 4.5 billion years old. Life on Earth, in terms of single-celled organisms, probably appeared something like 3.9, 3.8 billion years ago after all of the heavy bombardment with, and that term is probably needs to be qualified a bit, but anyway, all of this meteoric material that was left over from the formation of the solar system essentially assaulted the Earth and the other planets, subjecting them to a huge battering. And only once that was over was life able to start going on its path. There have been several major extinction events in which life has nearly been completely obliterated, of which some people say that we are now entering the sixth of those extinctions with the Anthropocene. But essentially, out of all the species that have come and gone on the Earth, we're the only ones probably that have reached the level of sophistication that we're capable of sending messages, for instance, in spacecrafts to other worlds. So the thing is, back in Percival Lowell's day, there was sort of this idea that life marched inevitably from very simple life forms to the more advanced ones. And, you know, it was a little bit like the ladder where humans were perceived to be at the top of the top rung and superior to everything else, including the primates. And I don't just mean the primates of England, and then other kinds of creatures that were below us, the animals and so on, down to the lowest life forms. Well, the reality is, as Stephen Jay Gould used to like to point out with the example of horses, horses are often used as an example of this evolutionary progression. They started out, they were small little creatures with 3 toes, and then eventually they lost the toes, they got larger, but they really haven't been a very successful species because there's only one species of horse. And similarly, even within the last 100,000 years or so, there were other species of hominins that inhabited the Earth at the same time we did. There were Neanderthals, as we know. There was the Denisovans, as a sort of a mysterious other species that lived in Eurasia. Homo erectus seemed to have survived until maybe about 30,000 years. That was a common antecedent of all of this. All of these hominin species. So actually, and we barely made it. There's evidence that there were only about 1,000 individual humans about 70,000 years ago at about the point where members of our species exited from Africa and then started its colonization of the rest of the world over the next 40 or 50,000 years. And finally reached Tierra del Fuego on the southern tip of South America only about 14,000 years ago. So, you know, we barely made it, and there's no real certainty, at least in my mind, that the adaptations that allowed us to survive thus far might not end up being lethal mutations. So the real question then becomes one of, you know, perhaps life like ourselves, intelligent life, as we like to call ourselves, though that's certainly in doubt these days, that maybe we're very rare and maybe we don't last very long. You know, maybe some of the things that have allowed us to cope in evolutionary terms, like our aggressiveness, our acquisitiveness, our lack of ability to cooperate with others, to be able to put our vices down enough so that we can create a sustainable life that is equable to enough people so that we can survive. Maybe that just isn't evolutionary in our genes, and we'll be gone in another couple hundred years. So if you look at that, and you look at how many stars are in the galaxy, and you look at how many planets are around those stars, and you look at how many of each of those planets might be Earth-like enough to be able to have evolved life like us, it turns out that the whole galaxy, according to a computation by a couple of very ingenious British cosmologists, there may be about 37 of these civilizations in the galaxy at any given time. And since the galaxy is over 100,000 light years across, that means that not very many of these are going to be within range of our communicating with them in 200 or 400 years. So, whether we are rare or whether we're common is a moot point. And personally, I think a lot's going to be determined about that future of ours in the next election.
Well, the other factor that I think needs to be put in here, a lot of people are under the mistaken impression, and that was certainly the case with Percival Lowell and his contemporaries, that evolution was an increasing complexity and sophistication process. In other words, you start off simple, as Bill said, and you get complicated and complex. That's not necessarily the case either, because evolution is a random effect for the most part. And then the selection of the environment at the given time is what really tells you, okay, you will survive. That's what when Darwin said survival of the fittest, he didn't mean the strongest, he didn't mean the smartest, he meant the animals or plants that survived were the fittest for a given environment. And for example, if we now have massive changes in a global climate, for instance, there's going to be a huge shift in terms of populations of plants and animals and populations of humans, where we live and how we survive and how many survive. So the entire process of evolution continues unabated. Whether we think we're the pinnacle of creation or not, doesn't matter. My point is that I think in many ways we have the tools, we have the ability to actually adapt and work in future and survive, but that's, as Bill suggested, not necessarily guaranteed. Now, others have argued more recently as well that we may not survive in our organic form, but we might survive in a technological form. For instance, cyber robots or whatever else. The next, we might in fact be, if any of you, again, coming back to science fiction, if any of you have ever read the series by Isaac Asimov called the I, Robot series, where in fact robots are too smart that they eventually outsmart us, and humans actually have to program in such a way that they can't do that. But the possibility, of course, is that with artificial intelligence, and already we're seeing that many machines can do things that we can't keep track of or pace with. So maybe our ancestors, our not ancestors, but our descendants are going to be intelligent machines. And in fact, some astronomers...
Scans of Mars have sifted through our hourglass. I'm being told that we're getting the message that our time is almost...
We're done. Okay.
So thanks so much. The loss of water in the early history of Mars, quick answer to that. It's probably a complicated business, but mainly it is that the intense ultraviolet radiation on the atmosphere caused dissociation of water into hydrogen and oxygen, and those basically, because Mars has such lesser gravitation than the Earth, was able to escape away, and so most of the water was probably lost by that. It's called the Gene's escape mechanism, and we're going to be back again next week by popular demand. And assuming that life doesn't end between now and next week, we'll see you then.
And Bill, before we go, let me just announce the answer to our trivia question.
Did anyone get it?
Yes. Yes, we just lost the name here, but his Twitter handle is Book Davies. He was the first one to answer. And the answer is Clayton Kershaw, tonight's starting pitcher for the Dodgers and future Hall of Famer. His great uncle was Clay Tumba.
Wow.
Congratulations.
We'll come up with another trivia question for next week.
Thank you all for listening, and good night.
Yep. Happy Halloween.